All right, last time we were continuing to talk about code smells and we have a few of them to go. I'm hoping to get close to or actually finish them. The plan for tomorrow is to get you a bit of programming practice, especially something that is either somewhat ape related or something that will indirectly help you with that. The last one we talked about, we're in the middle of talking about dispensables and we talked about duplicate code. So we talked about how programmers are going to be working on different parts of a project at the same time and may end up writing solutions to the same problem at the same time. Identifying later on that two pieces of code are calling the same logic that is written in two different places could help you to make your project smaller. So it's dispensable, you can just get rid of it. Next one we're going to talk about is a data class, which means that we make an object and that object only has state and doesn't have behavior. It doesn't have any methods other than getters and setters for those fields, so it doesn't actually do anything. It's a state-based object. We call this a data class. And usually this just means that all we can do is interact with state, which means that it should be embedded in other objects. So things that you can do, figure out where is this data, where is this state being used? If it's only in one or two places, you can move this state to be inside of those classes and then get rid of this data class. So you can move the code that uses the behavior of the data into and make that field of those classes. Now note that this data class may be used in many different areas, in which case it's not going to be worth doing that because you're going to be copying and pasting your code 8 or 10 different places to make it embedded in the state of that object, in which case the data class may actually have some validity and some purpose as an abstraction. But if that's not the case, then you may be able to just straight up get rid of the data class. One thing to note with this is that you may end up changing how the encapsulation of the object that it gets stored in works, because right now it's freely being accessed via the getters and setters. If this is moved within that object, maybe you don't want that object to have direct access to those fields and methods. So it's worth considering the encapsulation of that. Does that make sense? So you're moving state from this object to another object. If that object was originally only using the getters and setter methods, because this object should not have access to this state in this data class. Actually draw this out because I think that would be a little bit more informative. We have our so this is some other object. And this object is using the material from this data class. So let's say, for instance, that it has access to 1 out of 3 setters and 3 out of 3 getters. So it's only using 1 out of the 3 setters for this, and maybe this data class doesn't even implement setters for the other 2 fields. So this would have 3 fields, field 1, field 2, field 3. This one is freely editable, but these 2 are locked. And so you don't want outside modification of them. So when this object is calling this setter, it has read access to all 3 fields and it has write access to one of the 3 fields. If you were to move all of this structure, all 3 of these fields into this object class, then any methods that existed inside of this object would have free read and write access to all 3 of the fields. So if this object should not have write access to these 3, to all of the fields, then moving them into this object creates an encapsulation issue. So just something to be aware of. When you're removing setters or when you're changing things, just make sure that the appropriate encapsulation is being adhered to. You don't just want to freely move it because that helps me get rid of the data class if this object shouldn't have access to that modification. That make more sense? So as you do this, understanding an organization of code will increase. It can help you figure out where is there duplicate code. If you have a data class that data is also being stored somewhere else, if you remove the data class, then you may be getting rid of duplicate code. So data classes are just worth looking out for in general. All classes should have some kind of associated behavior where possible. The only time you would really want a data class is if it's an abstraction of fields that are all referenced by a bunch of different objects. Questions on data classes? Next one we'll talk about is a lazy class. So you can identify a lazy class with a class that just doesn't do much of anything. This happens a lot in industry when you receive the requirements and specifications for a project, and then you start implementing all of this, and then your manager comes back or your client comes back and says, you know what? Actually, we don't need this full functionality. Let's reduce it in scope down to, instead of being these 10 things, let's just make it this one thing. So as you do this, what's part of what you implemented to handle the 10-thing requirements and specifications may change as it goes down into a single requirement. So it was designed to be fully functional, but after significant refactoring or after the requirements change, then you don't have very much for this class to do. You can also find one, designed to do future work that never got done. So we have this grand design, and then we end up just really shipping a prototype. So if you identify a lazy class in your project or in your code, you can move the class into another one that does nearly the same work. And that just means that you overlap the requirements and functionality between the two objects. So this does a slight modification of A. Maybe you can merge them into one class that does A and the slight modification of A, and then you end up with fewer classes and less overall code. If it's part of an inheritance hierarchy, you can collapse that inheritance hierarchy and say, maybe instead of having two different subclasses and a superclass, we can just collapse it and just have a single class that ends up being less work. Because the original inheritance hierarchy was designed for more functionality than we ended up having. As you do this, you reduce the amount of code, which is good as long as you maintain the same level of functionality. Easier maintenance. If something goes wrong, you have fewer places to look to identify where the components of what went wrong lives. Questions on a lazy class? Next one we call dead code. Identifiable when you find some aspect of your code, could be a variable, could be a method parameter, could be a field in a class, a method in a class, or the entirety, an entire class that's just straight up not used anymore. This could arise when requirements change. Maybe you implemented a new version of this old class and kept the old class around for some reason, it just hasn't been deleted yet. If the requirements have changed, you can find that you have implementation of something that's just not used anymore. For instance, you could have a conditional and find that one branch of that conditional just straight up, there's no way to get to it anymore. There's an else if somewhere where that Boolean cannot be true given the requirements of the rest of this statement. So we can just delete that else if out of the conditional because there's never any time the code inside of that else if is going to be reached. If you use an IDE like IntelliJ or Eclipse in Java, then you can find these issues automatically. You will actually get a warning, a yellow squiggly that says this condition cannot be reached, or this code is never called. If you get those kinds of warnings, it's worth asking, do I really need this code? What is the use case for this code? If the answer is there is no use case for this code, you can delete it. So delete any unused code. There may be a reason that it is there though. So if it is not something that you wrote, if it's something that your coworker wrote, maybe you should talk to them about it and figure out, why did you write this? Is this code actually needed? Can we delete it? Rather than just making the assumption. Questions on dead code?
Like, in the industry, when you do this, so it might go through a process of change
Yeah.
approval before you
Yes.
can delete it, right?
Yes.
Okay.
Yeah, absolutely. We do code reviews for these things. Code reviews are used usually when you're writing new code and you want to make sure that a second set of eyes or a third set of eyes look at your code and figure out, is this code of significant quality? Does it, one, do what it's supposed to? Two, does it conform to the requirements of the code specifications for the company? Should it be allowed into the code base for this application? It's not just you write code, you commit code, we're good. There's always a code review process, but there's often a code review process as well for removing code. So you will identify potentially obsolete code and get a second set of eyes on it to say, is this code really needed? Yeah, there is a process for this in industry. If there is not, make some noise and make sure that that process happens, because otherwise it's just going to be a giant mess. The entire process is going to be a giant mess. We'll talk about this a lot more in software engineering, where you're actually going to be going through this process of making an application and learning how the industry deals with all of these issues. But yeah, a lot more coming in 350. Other questions? Next one is called speculative generality. This is just in case code. And you will write a lot of just in case code to support future features. For instance, if you want this feature to work when you design it out of the box, you will write a lot of the supporting code for that feature before you implement the feature, because you can't test the feature unless you have written the code to fully interact with the feature. So you will write code for something that eventually gets cut from the project or it's just not needed anymore. So you can, of course, we already talked about removing code that's not used. You may have to refactor your code to, if there was a call to this code that is not actually being used, then you have to look at that code and figure out that maybe there's a process to go through to identify what is the full scope of the code that's not being used. So this is not always bad, having this just in case code, especially as code that's not being used. If it's not being used right now, that does not necessarily mean that it is bad code. If you're designing something like a framework, the functionality isn't necessarily going to be used by the developers. It may be used by the client in real time. So there may be some feature there that there's no way for you, the developer, to interact with. There's only a way for the client to connect and interact with. So having a general understanding of the entire scope of your project is necessary as a developer, just to be able to think critically about the code that either you wrote or did not write. There may be some unit tests that depend on code that looks like speculative generality. So if you just remove code and there is testing code for that, even though there's no feature for it, you may have to go back and reference the test suite to say something like, maybe these tests aren't necessary because they're testing functionality that has since been removed from the requirements of the project. Questions about speculative generality? Kind of a mouthful. That's all we have for dispensables. We're going to move on to the next category, that is couplers. So we're going to talk about something called feature envy, and just in general to introduce the concept of couplers, this is where we have code that relies on other code. You can't have code in class A work without having class B, so it's very tightly coupled. Class A and class B work very much in tandem. Now, that's not necessarily a bad thing, but you can find times when your code is too tightly coupled, where you want to use A independently of B, a use case for that. But since it is so tightly coupled, you have to instantiate a B. You have to be using a B in ways that aren't relevant to the problem that you're trying to solve. So that is code that is too tightly coupled. So feature envy is a method that is going to be accessing data from another object more so than its own data. So think of this like you have two different objects, and object A needs to do something. But to do that, it's going to be manipulating object B significantly more than it manipulates itself. This comes about whenever you're doing significant refactoring. If you move fields or methods from one class to another class, you will find that a completely unrelated method that was in that original class starts to have feature envy, where it's now manipulating the new object where the fields or methods ended up, rather than its own class anymore, which means that that method should probably also move along with the other fields and methods that moved. So when you identify feature envy, you're probably going to be figuring out where is the new home for this functionality that is manipulating something else more than itself. So whenever you move fields or methods between objects, ask if the methods that use those fields or methods should also move along with them. As always, there's a but. So there may be reasons for them to stay in their existing class. So this is more of a general guideline, as most of these are, rather than a hard, fast rule of make sure that everything that uses them moves along with them. So if we wanted to come up with a general rule, try to adhere to this whenever you can. Methods that use data should be in the class where most of that data is, and not be trying to call class A dot get something dot get something dot get something dot get something that uses a bunch of stuff from some other class rather than direct access to its own fields. Does that make sense? So as you do this, you get less code duplication, which is good. You get better code organization. We'll find this a lot with couplers. Couplers deal with a lot of duplication and organization issues. Questions about feature envy? Next one, inappropriate intimacy. It's a valid name for it. So we have one class that is using the private fields and what should be the private fields and methods of another object. So we're breaking encapsulation, violating encapsulation. So good object-oriented design says that if you have different classes, they should know as little about each other as possible. And that way, if class A needs something from class B, it has to ask for it first through its getter method rather than just taking it. So all fields should be private or protected. And it should be, all of them should be accessed through getters and setters rather than just making them public and accessing them directly. If you notice, that class A really needs access to a field that's in class B a lot, you're back in feature envy, where we should be thinking about moving the methods from one class to another class so that you're not always asking that particular class for its information. It's like having another student in the class who is way smarter than you and just always has the right answers. Instead of bugging them all the time for the right answer, if you learn it yourself, then you don't have to bug them anymore. So in general, ask yourself, do these classes associate? Do they actually communicate between each other, or is one class just always asking the other class for information? So we don't really want bidirectional association wherever possible. We want unidirectional association wherever possible. So a class that's asking another class for something, a class that is sharing something with another class. We don't want something saying, I will share this with you if you share this with me. That's generally bad design. So if you identify an appropriate intimacy and fix it, then you can get better code organization. And of course, it simplifies support and code reuse because you don't find yourself accessing fields that you shouldn't in your code, which means that the state of the object is modifiable outside of the scope that it should be modifiable in, which means you'll have fewer bugs and fewer need to support your code. Questions on code inappropriate intimacy? Next one, incomplete library class. We find this a lot when we are trying to use an external library in our code, and we want some kind of functionality that is not there. What we frequently find, rather than borrowing the library, is that you write your entire library, reinvent the wheel. We want to instead write our own code that calls that library's methods. Does that make sense? So we're familiar with when we say write your own code that wraps the library. It's kind of like the decorator pattern that we talked about, where we're going to add functionality on top of something that already exists. We're going to take that library, and if we want if the library implements some of what we want, we then write some logic, call the library's calls, get back something from that, and then finish off what we're trying to do. And then we don't have to reinvent the wheel of what that library does in our own method. So you can borrow functionality, incomplete functionality that someone else has written, even if it's not doing exactly what you want, and you'll save yourself a ton of time writing and implementing code that someone else has already written. So you don't need to go find exactly what you are looking for in a library call. Go find something that is close and convert the logic into what you need. So you're writing kind of a decorator to a library. So you can introduce a foreign method or introduce a local extension, depending on the size of the change that needs to be made to the associated library call. As always, Refactoring Guru has really good explanations for exactly what that looks like. If you do this, you're not writing your own code that is done in an existing library, so you have less code duplication. Questions on an incomplete library class? Very frequently, CS students try to do this. They go try to find a library that does exactly what they want. Maybe you find something that's close and requires very little work for you. It's not all or nothing. Message chains. So we have method A that calls method B, that calls method C, that calls method D, that takes information from method A. So we have this really long method call chain. And then we have an object that we pass from method A to method B to method C to method D. And it's the same object that's being passed all the way down that chain. You see this a lot when you have things like client-server communication. So the client requests something from a server. The server doesn't have the permissions to directly access it. So it's going to access another server and say, hey, can I get this thing? And then that server requests something else. So it goes up the chain of hierarchy until you find someone who has access to that. And then it gets returned to the entire sequence of calls. You can think of this kind of like a bank statement request if you wanted to query something like the account balance. We talked about this in the UML slides, where you would have a client requested of the bank requested of something else that's storing exactly that. There are just different levels of security for each of those, and none of these should have direct access to account balances. So you can do what's called hide delegate. Go take a look at hide delegate. So client gets object B from a field or method of object A, then the client calls a method of object B. Instead of having all of these related arrows toward each other, we can have the client class request something from the person requesting something from the department and have that return it. One thing to know about the drawback for this is definitely a man-in-the-middle attack. So when you have all of these different levels of communication between objects, once you get to the object and it's being passed back and back and back, if there's anything listening in on any of those connections, they can grab something that they shouldn't have access to. So it creates a big security vulnerability and is very worth considering. So you can reduce dependency between classes and chains if you directly relay it to the original caller. So basically you would pass in an additional parameter. Here is who to send the result to. Here is who to send the result to. Here is who to send the result to. And then the final place sends it directly back rather than through the entire chain. It just goes directly back to the source. So we already found a middleman coupler. So if we're too zealous with message chains, then we need to delegate work to another class. This is very similar to hiring an employee who knows nothing and then just forwards every issue he or she encounters to the same help desk to get their result. So you're creating an unnecessary middleman who all they do is forward the work onto somebody else. So we can remove the middleman by just taking wherever the middleman sends things, have whatever sends something to the middleman, send it past the middleman, then we delete the middleman class and reduces your code. Of course, there can be times when it's necessary to have this middle class. If you have interclass dependencies, if there's a security process that the middleman is making sure, like authenticating the what's coming in before it sends it out. So the middleman can't have actual reasonable real functionality. So some design patterns will have a middleman on purpose. Decorator is one of those. Proxy is also one of those. We are out of time. I was kind of rushing here at the end because I wanted to reasonably get to the end of this. We can come back to a few of these and talk about them in more detail next week if we want to, but again, the plan for tomorrow is to hear less of me talking and do some more coding. So I will see you tomorrow for that. Let me know if you have any questions about the assignment, the lab that is now due Monday. I did upload the decorator lab as well. So if you finish the strategy lab, you can get started on the decorator lab, and I would recommend that because we want to get that done and in as soon as possible so we start working on your project. It's going to be more fun than these labs. I'll see you tomorrow.
thank you for the time on that, on the due date.
Yeah, yeah,